Welcome to Foundations Are Us, where we build knowledge from the ground up.
All right, let's go through the Lot 76 breakdown. All the critical elements on this plan, with everything clearly highlighted so you can understand exactly what's going on. Here's Lot 76, and I've color-coded all the important features. Starting with the top of the foundation wall, highlighted in pink, we are at 223.40 meters above sea level. Then we have the underside of footing, also in pink, at 220.57 meters above sea level. These elevations define your structural foundation height and are key for everything that follows. Next up, highlighted in yellow, we have the model type. This is a G30H MO modern elevation. And this one is also a reverse plan, meaning that the porch is on the right-hand side instead of the typical left. Now let's zoom in on blue. Now let's correct something important. The blue highlighted area is not a sunken garage. It represents a sunken landing at the back of the garage. In this case, it's a one-riser drop. That translates to a roughly 7.5-inch drop from the top of the foundation wall down to the sunken landing. This is a small but critical detail because it affects transitions, drainage, and how the slab steps down in that area. Let's zoom to the green highlights. All the green highlights around the foundation show a difference between the top of the foundation wall and finished grade. This is one of the most important parts of the entire drawing because it determines how the house will sit on the lot visually, how much brick veneer is required, whether veneering is needed at all, and it makes preparing the cut sheet much easier. Front entry explanation. At the front, we're dealing with the 5-riser condition. That means 5 steps up from the garage slab to the porch, and then 1 additional step inside to the home. So your elevation change is split between exterior and interior access. Calculation section. From here, what we're going to do is take the top foundation wall elevations and compare them against the finished grade elevations. That gives us the vertical differences when we need for constructing planning. Imperial conversion note. Now here's the key step. Even though everything here is in metric, we have to convert to imperial. That's because in low-rise residential construction, all working drawings and cut sheets are done in imperial. So accurate conversion is essential before moving forward. That's Lot 76. Once you understand these relationships, everything from grading to steps to finishes becomes much easier to plan. Now let's dive into how to calculate the finished grades around the foundation walls. Okay, now what we're going to do is we're going to establish the grades around the home, taking the top foundation wall number here, which is 223.40, and we're going to take away the finished grade numbers in green all the way around the foundation to determine how much exposed concrete we have across the entire envelope of the building. For example, if we have 6 to 12 inches of exposed concrete, after we subtract the top foundation wall number to the finished grade number, then no brick veneer is required. We can leave it standard. If we start getting into situations where you exceed that 12 inches exposed concrete, start getting into the 16s, the 18s, the 20s, the 24s, then what we have to do is implement what's called brick veneer. Anyways, let's get into some calculations. So let's do that. We'll start it right at the back. So we have, again, our foundation number is 223.40. And we're going to take away 223.25, which is 15 centimeters. And again, remember, we have to convert this into imperial. So that ends up being 6 inches. And we'll just highlight that. Moving around the corner. Again, top foundation wall number, 223.4. And we're going to take away, if I can read this properly because it's very small, 223.04, which leaves us with 36 centimeters or 14 inches on the corner. So we'll write 14. On the other corner here, again, 223.40, take away 223.14. Leaves us 26 centimeters, converted into imperial, is 10. So now we have our grades established in the back. 10 inches of exposed concrete, 6 inches of exposed concrete, and 14 inches of exposed concrete. So what we know now is that there is no veneer or anything else required in the back. It's a very standard elevation home in the rear. Now we're going to move alongside to the garage at the front. So again, our 223.40 number, our top foundation wall. And we are going to subtract our 227.75. And that leaves us with 64 centimeters or 25 inches. So we're going to write 25 here at the corner. And the garage is the same number. So we're going to write 25 here at the garage. Now we're going to get right in front of the porch here. Again, 223.40 minus 222.6 leaves us with 80 centimeters or 32 inches. So we'll write 32 inches right here. And then finally, our last number here that we're going to calculate, again, 223.40 against 222. Oh my goodness, I can't even see it. 68 is going to leave us with 72 centimeters or 28 inches. So that makes total sense. So what you're going to see here now is that we have a pretty standard elevation, grade in the back with an apron swale, bring the water there, and then it comes down. So this is a rear to front drainage home. So all the water is going to travel through that swale. It's going to come down the side of the house, and it's going to go all the way through, and it's going to dissipate into the front yard and the sidewalk and the curb and all over through the street and catch basins, etc., etc., etc. So here we have a pretty typical front where we have 25 inches of exposed concrete at the front of the home where the garage is, drops to 32 in front of the porch, and then climbs up at 28. So that means we do have positive drainage away from the home, coming away down, 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 and down, and then coming back up to meet this swell up here. So that's how we calculate our grades around the home. These are the critical grades around the house. This will help us determine our brick veneer, if required, for when we do our cut sheet, which we will, as we can tell these numbers, we do not want 28 inches or 32 inches or 25 inches of exposed concrete on a home. We want to sit around 12 inches of exposed concrete. I find that looks the best in terms of a look. It's a good golden rule to stand by. And the last thing to go over in this video are the sanitary and storm inverts. You can see on the site plan that it indicates a double connection, meaning that one trench will service 2 lots. This is a much more efficient way compared to the developer installing individual services to each home. These connections typically fall between 2 driveways. The most important element here is verifying the lateral invert elevations for both of the sanitary and storm are lower than the underside of footing or USF. If they are not, water will not naturally flow away from the home by gravity, which is a very serious issue. If you ever encounter this situation, you must have the developer adjust the laterals before any connection is made. Also, keep in mind that sometimes the design drawings may show the acceptable elevations, but the field conditions can differ once constructed. That's why verification on site is critical. We require a minimum 2% slope for sanitary connections and 1% slope for storm connections. These are the absolute minimums, but more slope is always better. In this case, we are in good shape. The underside of footing elevation is 220.57, and the storm invert is 219.38, and the storm is typically higher than the sanitary, giving us a 1.19 meter drop. That is plenty of fall and exactly what we want to see. Builder notes. Always review all critical siting information carefully prior to construction start. Ensure all required elements are clearly identified, as conditions and requirements may vary from site to site and between municipalities. Always verify the following: top foundation wall, underside of footing, model type, standard versus reverse model, sucking conditions, and front porch risers. These elements are essential to establishing proper elevations and overall build accuracy. Calculate the difference between the top foundation wall and the finished grade around the home to determine the elevation difference between the top foundation wall and future grass levels. This step is critical to achieving proper drainage and visual consistency. Always convert metric values into imperial measurements, as low-rise residential construction typically builds using imperial standards. Target approximately 12 inches of exposed concrete from the bottom of the brick to the finished grade. This provides a clean, consistent appearance and ensures proper placement of finishes. Accurate siting calculations will ensure all required brick veneer, if applicable, is properly positioned resulting in a high quality and visually consistent finished home. These aren't just suggestions, they are requirements. Proper siding directly impacts drainage performance, structural integrity, and overall build quality. Well, everyone, that's about it for this one. Remember, this isn't just paperwork. If your elevations are off, everything downstream is a problem. Get your siding right, verify your numbers, and you'll avoid major issues on site. We'll see you on the next one. Thank you for tuning in to Foundations R Us, where we are building knowledge from the ground up.